In this lesson, we will discuss function rules, tables, and graphs. Now, there are a couple things whenever we have a table or a graph or something like that with functions, we have inputs and outputs. Now, you've probably heard of independent variables and dependent variables, and you didn't really know what they were. Okay, but anytime you were going to input a value into an equation, that is your independent variable. Okay. And usually if you graph that, you're going to put that on the horizontal axis as noted here. And then whenever you put that value into an equation, you're going to get an output, which is the dependent variable. Okay, and I'll point that out as we move along, but that dependent variable, it will usually go on the vertical axis. Now if you think about that, that's going to be the x-axis and that's going to be the y-axis. So the input is going to be your x values, and your output after you figured it out is going to be your y values. Okay, as we can see here, it says use the input and output values as ordered pairs to plot points. Okay, so you put your input and you put your output that came out from it, and that becomes your coordinate points. Okay, as we move along, we're going to see that if we are modeling a function, if it asks you to model a function, we're going to choose some input values that would make sense with what we're doing, and I'll show you that in an example. And then we're going to evaluate using those input values, and we'll get some output values, and we'll be able to plot a couple points and connect the dots. Okay, so keep that in mind as we move along and look at example 1. Okay, so example 1, it says model the function rule y equals 1/3 x plus 2 using a table of values and a graph. Okay, so the function rule is pretty much just the equation. Okay, so if you ever see function rule, it's essentially the equation that we're using for the particular problem. Okay, I took the liberty of going ahead and drawing a table and a graph that I can use just to be able to organize the notes, but for you, you will just use the lines of your paper and make you a little table. Okay, so in this problem, okay, we've got y equals 1/3 x plus 2. So we need to pick some input values. Okay, since we see that we've got a 1/3, why don't we use something that we know will give us a whole number, like say 3 or 0 or -3, something like that. Okay, that way we know that we can get a whole number to as our output value. Okay, so that's what I'm going to do. I'm going to use, let's go in order from least to greatest. I'm going to use -3. Oh, I'm sorry. We'll use -3, and then we'll use 0, and how about a +3? Okay. All right, so we're going to plug that in to this equation. Okay, so we're going to get y equals 1/3 of x, which is going to be -1 plus 2, which will be a total of +1. Okay, and then right here when we plug in 0, that will be y equals 1/3 of 0, which is 0, plus 2 will be equal to a total of 2. Okay, last one, you have y equals, what is 1/3 of 3? That is +1 plus 2 is going to be equal to 3. Okay, so now I have my values. I have my inputs, I have my outputs, so now I can make an ordered pair. So I can have -3, 1. Now I'm going to have 0, 2, and 3, 3. Okay, so that's the coordinate points that were established based on our inputs and output values. Okay, now we need to graph this. Okay, I finished my table of values. Now I need to graph it. Okay, so I have just a basic graph set up. We've got my x and my y plane, okay, or y axis. Okay, so I'm going to take that -3, so I'm going to give me some numbers to work with, or some lines to work with. Okay, alright, -3 and 1, so there's 1 point. Okay, 0 and 2, and 3, 3. Okay, and then it just says simply to connect the dots. Okay, so that's what we'll do. Okay, I'm going to use my little line tool here. You get to use a straight edge if you want to. That's just up to you. Okay, just draw your line through that, and that will be the graph of y equals 1/3 x plus 2. Okay, so we put our table, or use our table, and then graphed it. Okay, so moving on down, let's look at example 2. Alright, this one just says that we will graph the function y equals the absolute value of x plus 2. Okay, and I went ahead and cheated with a couple of lines right here, but you can just use your lines on your paper as I said. And we're going to choose some values for x, and then we're going to plug in with our rule. Okay, so we've got x plus 2. That's going to be our rule, and then we're going to look for coordinate points x and y. Okay, don't forget this is equal to y. Okay, so doesn't really matter what we use as long as we use whole numbers, because we'll get whole numbers with this. There's no fractions or anything, so let's just use, how about, since we see a 2, let's use a -2, a 0, and a 2. It's always a good idea to use 0 just because it's so fast. 0 is so easy to plug in and use. If you ever get the opportunity, I would say use it. And we like to have symmetry and having something on the left side and something on the right side, so that's why we typically use a negative number and a positive number. It really comes in handy. If you don't, sometimes you might end up missing what a graph is actually going to look like. Okay, so let's plug this in. We've got -2. What is the absolute value of -2? And it's 2, exactly right. So we got 2 plus 2. You've all been wanting to have a problem like that in math class for a while. So we got 2 plus 2 is 4. Okay, the absolute value of 0 is just 0. So we got 0 plus 2 is 2. Okay, and then the absolute value of 2 is 2. Okay, which is 4. Okay, so our coordinate points now will be -2, 4, 0, 2, and 2, 4. Okay, so let's take a look at that on the graph. Okay, so we've got back 2, forward 2. I kind of cheated and knew that my graph was going to be up above, so you may not have known that ahead of time. Okay, but let's put in -2, and it would give us 4. So we're going to put a dot there. Okay, 0, 2 gives me a dot there, and 2, 4 gives me a dot there. Okay, if you do this many times, you may end up wanting to check out, if you're not sure if this is like a curve or whatever, you may want to go ahead and plug in some more points just to prove to yourself that it is going to end up being straight lines. But I can assure you that with absolute values, you are going to get straight lines. Okay, so let me go ahead and show that. You're going to have from here, it's going to go out this way, and from here, it's going to go out this way. Okay, so you're going to end up getting you a perfect V. Okay, very simply, that anytime you see absolute values, you're always going to see a very angled change of direction. Okay, you're going to see an example in just a second of a curve. So make sure you take a look at that very carefully. So let's move on down. Okay, a little too far. Okay, and once again, like I said, I kind of cheated with my table here, but you need to write that down also. So now it says graph the function f of x is equal to x squared plus 2. Now I want to go ahead and give you a warning. F of x, I believe we discussed this in the class yesterday, f of x is the same thing as y as far as how we use it. It's just a, we say that y is a function of x, so we go ahead and put f of x, meaning the function of x. Okay, so in my little table, I'm going to put x here. I'm going to go with y equals x squared plus 2 here, and then it's going to give me x y. Okay. Now, some people would go ahead and write f of x instead of y there, and they would also go ahead and put that same thing here. Okay. So if you see that, it's the same thing. I like to go ahead and work with y just because it's a little less confusing to me. Always was when I was your age, and so I try to do that same thing. Okay, so I'm going to plug this in. I'm going to say we need a few values right here. I'm going to go ahead and work with a few more than just 3 this time, but you need to get to where you recognize that when you see a square, a quadratic equation, then you need to realize it's going to be a curve. Okay, but I'm going to go ahead and prove that to you right now. Okay, so I'm going to use negative 2, negative 1, 0, 1, and 2. I'm going to go ahead and use 5 of them. That way I can prove it to you. Okay, so negative 2 squared is going to give me a positive 4. Okay, so 4 plus 2 is going to give me 6. Okay, negative 1 squared is going to give me a positive 1, so 1 plus 2 is equal to 3. 0 squared is just 0, so 0 plus 2 is equal to 2. Okay, 1 squared is 1 plus 2 is equal to 3. And 2 squared is 4 plus 2 equals 6. Okay, so that gives me the coordinate points of negative 2, 6, negative 1, 3, 0, 2, and 1, 3, and 2, 6. Okay. Alright, so let's try to graph this real quick and then we'll be done. Okay, so I've got my couple points going out. Okay. Alright, once again, I kind of cheated and knew that I was going to be going kind of taller. So I'm going to go ahead and do that. Okay. So if I go back 2, I'm going to be up here at 6. Okay, if I go back 1, I'll be at 3. If I go to 0, I've got 2. And if I go to 1, it'll be at 3. And if I go to 2, it'll be at 6. Okay? Now, it's kind of hard to tell when this is not zoomed in, but when you get this, it's going to be a curve. It's going to look like a U, okay? So, I'm going to change colors real quick and let you see that this will be a U. Okay? Obviously hard to draw on this, but if you draw your own graphs and spread it out a little bit, you'll be able to see that much more clearly, okay? So, test that out for yourself. Work a few problems if you need to. Ask questions during class, and we'll see you tomorrow.